Hello students, welcome to St. Angel's online classes. Students, we are working from home. So today we are going to start chapter number 11, which is 3D geometry. Okay, so we have studied 3D geometry in the 11, but that wasn't just an introduction. Okay, so now in the chapter 10 we have discussed about the direction, ratio and cosine. So that we have studied in the respect of vector. Now we will study them in the respect of a straight line. Okay, so suppose in the 3D system, this is my x-axis, y-axis and z-axis. Suppose there is a line L which is making angle alpha with x-axis, angle beta with y-axis and angle gamma with z-axis. Okay, so now alpha, beta and gamma are known as direction angles. So in the chapter 10 in vector we have studied that cos of these direction angles are known as direction cosines. Okay, so in the vectors there was a specific direction of a line, but suppose this is x-axis. Okay, origin positive x and minus x. Okay, and there is a line L which is making angle alpha with the x-axis, but in the this was like if I am taking line in this direction, but if I am talking about the line in the reverse direction, then it's making an angle of pi minus alpha. So pi minus alpha is also a direction angle. Similarly, pi minus beta would be a direction angle. Pi minus gamma would be a direction angle. So what? Direction angle. So cos pi minus alpha, cos pi minus beta, cos pi minus gamma. These are also the direction cosine. It means what? Cos pi minus beta is minus cos beta. It means what? Minus cos alpha, minus cos beta, minus cos gamma. So one thing is very clear, that a vector has only a single set of direction cosines. Okay, but a straight line has two sets of direction cosine, which are cos alpha, cos beta, cos gamma, and minus cos alpha, minus cos beta and minus cos gamma. Okay students, and if you remember that we represent direction cosines by L, N, N, and direction ratios by A, B, C. Okay students, now please pause the video and note it down. Now we will learn the relationship between direction cosine. So there is a simple relationship equation that L square plus M square plus N square is equal to pi. Okay students, now suppose we have a line passing through 2 points, point P and point Q. Suppose the direction coordinates of this point P are x1, y1, z1, and coordinate of point Q are x2, y2 and z2. Then direction ratios of line PQ. Direction ratios of line PQ. It means A, B, C. But that equals to be x2 minus x1, y2 minus y1 and z2 minus z1. So hence L, M, N would be equals to x2 minus x1 upon under root x2 minus x1 ka square plus y2 minus y1 ka square plus z2 minus z1 ka square, and similar to the rest 3 are. Okay, so and this is the relationship between, we have already studied that L equals to A upon under root A square plus B square plus C square. So there is nothing new. Okay, so this is you already are aware of. Okay, now what we are going to study are very important. Now we will start a straight line in 3D geometry and we will discuss the different equation and forms of a line. So now we are going to study equations of line. Equations of straight line. Beta, in 11th class in the geometry we have studied straight line in 2-dimensional. Okay, and there we have discussed only Cartesian equation, but in class 12 we will discuss Cartesian equation as well as the vector equation. So first form is a line passing through a point and parallel to a given line vector. Okay, the first equation of line is a line passing through a point and parallel to a given line or vector. I could say parallel to a given line or in the direction of a given line. Parallel to a given line or point and in the direction of a given line and vector. It's the same thing. Okay, so now we'll have to derive this equation. So that's vector equation is, so vector equation of line which passing through a point and parallel to, that is r vector equals to a vector plus lambda b vector. This is the vector equation. And Cartesian equation is x minus x1 upon a equals to y minus y1 upon b equals to z minus z1 upon c. But now we will derive the equation. Okay, so suppose this is the line L of which we have to write the equation. So this line is passing through the point P and the coordinate of point P are x1, y1 and z1. Suppose. Okay, so that we will discuss later on. Okay, and there is another line or vector v to which this line L is parallel. So a line passing through a point and parallel to another given vector or line. Okay, so suppose the position vector of point P is A. Position vector of point P is A vector. Now take any random point on this line. Suppose I have taken point Q and let the position vector of point P is R vector. Okay students, what I have taken, that on this line I have taken a point which through which line is passing. So I have let that the position vector of this point P is A vector, and I have taken any random point on line, that is point Q, and the position vector of point Q is R vector. So beta now PQ vector would be position vector of Q minus position vector of P. Okay, so PQ vector would be equals to R vector minus A vector. Okay beta, now from here, since PQ, because this line is parallel to vector B, it means what? PQ vector is parallel to vector B, and we know that when two vectors are parallel, so I could say that PQ vector equals to lambda times of B vector. That was a condition to prove two vectors parallel. So I am using this and putting in equation number first. So that would be equals to PQ की जगह पे हम will put lambda B vector. Lambda B vector equals to R vector minus A vector. So from here we will get R vector equals to A vector plus lambda B vector. So this is the vector equation of a line which passing through a point P and parallel to a given vector V. So this is the formula, R vector equals to A vector plus lambda V vector. Here vector A is the point through which line is passing and vector B is the point, the vector to which the line is parallel. Okay students, and it's very simple in Cartesian form. Suppose now I'm just roughing out this one, I hope you got it. Okay, so in the Cartesian form, suppose this is the line passing through the point P whose coordinates are x1, y1 and z1, and another line whose direction ratios are 1, 2, 3. Then here in this formula, x1, y1, z1 are the points through which line is passing. So these are the points, and 1, 2, 3, suppose ABC, and ABC are the direction ratios of the line to which given line is parallel. Okay, so now we'll take an example and try to solve the question. So till then, please pause the video and note it down. Okay students, now we'll look at an example. So find the vector and Cartesian equation of a line through the point 5, 2, minus 4 and which is parallel to the vector 3i cap plus 2j cap minus 8k cap. So okay, so this is the line L of which we have to find the equation. Line is passing through the point P, the coordinates are 5, 2, minus 4 and parallel to a given vector 3i plus 2j minus 8k. So first of all, I am writing the vector equation of line L. But what was the vector equation? That was R vector equals to A vector plus lambda V vector. Here vector A is the position vector of the point through which line is passing. It means what? Vector A is equals to, this is the point through which line is passing. So vector A is 5i cap plus 2j cap minus 4k cap. And vector V is the vector to which line is parallel. So line is parallel to this vector. So vector B equals to 3i cap plus 2j cap minus 8k cap. So now put value of vector A and vector B in equation first. So the equation of line would be r equals to 5i cap plus 2j cap minus 4k cap plus lambda 3i cap plus 2j cap minus 8k cap. So that this is the vector equation of the given line. Now we will find Cartesian equation. So first of all, the point x1, y1 and z1 is 5, 2, minus 4 through which line is passing, and the direction ratios of the given vector. We know that in a given vector, the coefficient of I cap, j cap and k cap are direction ratio. So value of a, b and c are a, b and c. These are 3, 2 and minus 8. And with a value of x1, y1 and z1, it means the point through which line is passing, that is 5, 2, minus 4. So we know that the formula of Cartesian form of line, that is x minus x1 upon a equals to y minus y1 upon b equals to z minus z1 upon c. So now just simply put the value. So x minus x1 is 5 upon a value is 3 equals to y minus y1 is 2, the value of b is 2, z minus z1, so minus would be plus z plus 4 upon c is minus 8. So this is the required equation of the line. Answer. Okay, so now here I have written the Cartesian equation through the formula, but if we have given the vector equation of a given line, we can derive the Cartesian equation. So you have to know that. So I am just deriving the line or equation of line through the help of the vector equation. Okay, you can do it by this method or the method I am going to show. So it's all up to how would you want to solve it. Okay, so now r was the any point on the line. So r vector is always equals to xi cap plus yj cap plus zk cap. It means it's any random point on line L. This is a point whose coordinate are x, y, z, and then the position vector of point Q would be xi, yj plus zk. That was the r vector. Okay, so put r equals to this in this equation. So it would be xi cap plus yj cap plus zk cap. Zk cap equals to that. Here I am equating the coefficient of I, j and k. So coefficient of I are 5 plus 3 lambda I cap. Coefficient of j are 2 plus 2 lambda j cap, and coefficient of k are minus 4 plus minus 8 lambda k cap. Okay, so now if two vectors are equal, it means what? The coefficient of I, j and k are equal. So on comparing beta, x would be equals to 5 plus 3 lambda, y would be equals to 2 plus 2 lambda, beta z would be equals to minus 4 minus 8 lambda. So from here I am finding out the value of lambda. So from here lambda would be equals to x minus 5 upon 3. From here lambda would be equals to y minus 2 upon 2. From here I am finding out the value of lambda, that would be z minus plus 4 upon minus 8. Okay, so that would be value of lambda. Now these lambda equals to this, lambda equals to this, lambda equals to this. It means what? These three values are equal. It means what? X minus 5 by 3 equals to y minus 2 upon 2 equals to z plus 4 upon minus 8. This is the Cartesian equation of line. So it's all up to either you want to do it by the formula or you can derive it from the vector equation. Okay, so now please pause the video and note it down.